So we're in your chemistry book and we're in chapter 10 and on section 6 or 5 on the halogens. And these halogens we went over as being, in the halogens of fluorine and chlorine and bromine and iodine. And we got to the point we were discussing chlorine. This article is pretty important because it says the end of chlorine. So you think, what are they talking about? Well, the environmentalists in the back were thinking of banning chlorine because of the ozone layer. And so in the midst of all this, there was the major problems because chlorine is in almost everything. And this may cause like the end of civilization. So this article basically says every year 1.5 billion people die or suffer from preventable diseases such as, when we talk about diseases, we talk about cholera and typhoid fever and dysentery, amoeba, bacteria, gastroenteritis, giardia, and viral hepatitis, all these things. And chlorine stops these diseases and these bacterias. And so now the campaign, the environmentalist campaign, was to eliminate chlorine. And what will happen to all these diseases? Because chlorine being a major part of antiseptics and such. So the Greenpeace International met in 1991, as he says here, you see, was first launched, and it caused to completely phase out the use, export, and import of all organochlorines, elemental chlorine, and chlorinated oxidizing agents. And this was Greenpeace. Joe Thornton explained there are no uses of chlorine which are safe. Yet chlorination is considered one of the greatest advances in public health and hygiene and is universally accepted as a method of choice for purifying water. So without chlorine, would we even have pure water? There's another way of chlorine, besides chlorine, it would be use ozone, but ozone is very short-lived, and it hasn't been proved to be as safe or as efficient either. But anyway, the chlorine-based building block of the environment, coming to find out that chlorine also comes from natural things like volcanoes and forest fires and the decomposition of seaweed, fungi and algae and ferns and all these things release chlorine to the environment. So it's not only man-made chlorine, and even our own body produces chlorine to fight infection. Of course, we think of chlorine as a part of a compound that's very important when we think of sodium chloride. Sodium chloride being salt. So it's table salt. So will we have to even do away with table salt, with our salt and chlorine? And also sodium chloride is in mines and lakes and seaweed, and it's even found in our blood. Sweat and tears has sodium chloride salt inside our blood. And it's actually very essential in our diet if we don't have some sodium chloride in our diet. But this goal to eliminate all these things would be unattainable. But Greenpeace said they had absolute zero tolerance. Can you believe that? Zero tolerance for man-made chlorine. So, and saying that they're hazards, this would be a big problem. So, why did they get so on chlorine? Is because of course, we know the ozone layer, but there was an article by Rachel Carson. It's called The Silent Spring in 1962. And Carson was first to bear witness against chlorinated hydrocarbons and called them elixirs of death, created by ingenious laboratory manipulation of molecules. And through this article, her intellectual errors in the environmental movement embraced This mistaken vision of technology that considers only the risk factors and not all the good things that chlorine does. So, sunsetting all the uses of chlorine may reduce the hypothetical risks associated with such compounds, such as maybe dioxin, DDT, and PCBs. But at the same time, however, a blanket ban on chlorine would increase enormous risks of microbial, when you think of bacteria and virus infections here, as chlorine has been a major fight against this. So basic and antiseptic. Even more daunting, a chlorine phase out would halt the production of plastics. We couldn't have plastics, or maybe we couldn't even have pesticides or any chlorine containing drugs. So going back there, according to one industry-backed report, almost 85% of pharmaceuticals. So 85% of our medicines have chlorine in them. So basically they would ban most of our medications. And 96% of the crop protected chemicals are chlorine dependent. And what about our drinking water? So how important it is that our drinking water is pure. Onto our clean swimming pools and pest-free crops and flame retardants. And flame retardants is very important because chlorine is used in fighting forest fires. And food packaging is another thing. And quality white paper or bright white socks or saran wraps or plastic bottles or garden hoses, window frames or plumbing, pipes. Pipes are made with chlorine. And the end of chlorine would spell the end of modern civilization. So you can imagine without chlorine, we wouldn't have a lot of things. So basically, yes, we need to be good stewards of what's happening to our environment. That is sure. But is a blanket ban of a certain element that has so many good uses, wouldn't we need to consider that? So when we're talking to an environmentalist, we need to talk about these issues and how important it is that we know both sides of the story, So that article is very important when you're dealing with people that in school and stuff that say, okay, we need to ban things, especially elements. So let's go on to there's a couple more halogens here, and then we're going to go into some questions that are here. Excuse me. There's another halogen called bromine. So bromine compounds, and let's look at our, let's look and see where bromine is on our, we go in here. Bromine, we were doing fluorine, chlorine, bromine, and iodine. So let's talk about bromine and iodine. These are all halogens in column 17 that are very reactive. In fact, they rarely, you can see them in their original form without being in ion form. So anyway, bromine. Actually use declined in recent years because it actually, ethyl dibromine, EDB, right here, was once added to our gasoline. And now, because of there's lead in our gasoline now. Now there's no longer leaded gasoline, so we don't need the EDB added to our gas. So that caused very much of a decrease in the use. And on to the fumigant for toxic molds on crops, but then again, bromine was restricted on that too because of the environmental problems. So as we go here, methylbromine was another important agriculture fumigant, and it was widely used until the mid-1990s. And again, the Montreal Protocol mandated that it be phased out, and it was. So most bromine chemical bromine in the combinations haven't been used so much as in the past, just saying that. It was used in synthetics of halogens in firefighting, but again, even in the firefighting, it was banned in 1994. But today it is still used in things like dyes and pharmaceuticals, some pharmaceuticals, sedatives, fire retardants, and onto silver bromide is light sensitive and used for photos on films, and also it can be used as disinfectant. So we still use some of it, but as you see here, homobromous acid is used to disinfect water. Is another thing. So let's go on to iodine. And we look at iodine, of course, it's in that category of halogens. And iodine is an alcohol solution of 2%. It's called the tincture of iodine. And it's used in antiseptics. We used to use it in nursing for about everything, for cuts and scrapes. And before you put an IV in, you'd always wash everything with a tincture of iodine. Not so much anymore, more alcohol now. And thyroxine hormone is of the thyroid gland. And the thyroid gland, we find, needs iodine. So if you lack iodine in your diet, you could have an enlarged thyroid gland, or that's called goiter. And a goiter would be like a large, looks like a large gland right there in the front of your neck where the thyroid gland is. But now with potassium iodine and sodium iodine that iodized our salt, this will prevent thyroid, as iodine was added to our salt. So, and also silver iodine was also used to, some proposed to replace freons and halogens, and also used in high-powered lasers. These are some of the things that iodine have been used for. When you think of iodine, you think of a tincture of iodine. It used to be iodine was actually used for ink too, you know. So anyway, so here's a picture of the bromine, with bromine here with a molecule. So as you see, and onto here, let's go to this chart here of 10.3. The halogens and some of their uses, because some of the questions we'll talk, you know, that we're going to be asked is, what are these halogen elements used for? So here of course we have fluorine, the fluoridation of water, anti-cavity treatment, uranium fuel production, manufacture of refrigerants, PTFE and purofluorocarbons. Remember they use that actually, it's for breathing newborn infants. When their lungs to be able to breathe, they can actually breathe this even more than oxygen. And on to glass etchant here and high power lasers. Now to chlorine, the bleaching of paper, pulp, and textiles, disinfectants, water purification, household bleach, chlorinated solvents, pesticides and herbicides, plastics, and medicines. A lot of things that chlorine are used for. Bromine for firefighting chemicals, medicines, some purofluorocarbons, photographic emulsions, and water purification sometimes. And iodine is an antiseptic, an iodized salt for our thyroid gland, photography, onto refrigerants, firefighting, and high-powered lasers. These are our halogens. So questions here to consider. Let's look at these questions. The first says, give equations showing the commercial methods for preparing the preparation of halogens. So, and this is in your book. I'll put up here what I wrote here so you can kind of see. Hopefully you can see this well. I don't think you can see it that well. Let me see if I put it so you can see it right here. So here we go as we have the fluorine, chlorine, and you have the different equations. Basically, in taking the equation, you can plug in any one of these into the equation. And it's actually in your book. So it talks about the chlorine and preparing it is taking hydrogen sulfate onto, let's go back and look at it real quick so you can see. I don't think you'll have this as a question to test or anything, but see if I can bring it back to show you which, I was trying to show it to you in my paper, but it doesn't really work that way. Okay, here we go here. The laboratory, the preparation of halides. So here you have the halides except for fluorine here, but you have the preparation here. You can use this equation here. With fluoride, they use electric currents to go through, but with chlorine and with bromine and iodine, you can use this formula. And basically what they're doing, they're taking it from metal halide salt and heating them up with concentrated hydrogen sulfate here, concentrated, and doing this, they'll come out with having water and sodium sulfate, magnesium sulfate, and iodine. So that's how they have to take this salt and get so they can get rid of this. And this is the same one with down here. So anyway, you can see the equation there for each one. Tell how you would prepare chlorine gas in the laboratory. So to prepare chlorine gas in the laboratory, you would react it with hydrochloric acid and manganese. And in the midst of that, you'll be able to, at high temperature there, bring out the chlorine. So anyway, you can look back at that too. So what is PTFE? PTFE is polytetric fluoroethane. And it says give 3 uses of it. Basically, one be for high temperature plastics, cookware, non-lubricated valves, electrical insulators. These are all on your book here. So the basis for bleaching action of household bleach. What is the basis? And the basis of bleaching action is the hypochlorite ion, remember? Which is OCl. So that hypochlorite ion. 3 uses of each halogen. 3 uses, well, basically we kind of went over those uses on that there already, but you'd see the uses of bromine, synthesizing dyes, pharmaceuticals, sedatives, fire retardants, iodine used as an antiseptic and for the thyroid gland and lasers, and of course we have chlorine, bleaches and disinfectants, PVC pipes, tons of medications, and of course fluorine we have, you know, basically for dental hygiene and refrigerants and fluorocarbon. We went over all these already, so you should just be able to look those up. Let me go back just once here. Okay. Go back to the pretty important when we're talking about chlorine here. This is fluorine. Okay, chlorine here. This is kind of important and probably be on the test here. It says household bleach is 5% solution of sodium hypochlorite. So in which the active ingredient is the hypochlorite ion. This is the ion right here, what it looks like. So, and so it's important. Swimming pools are kept clear by the addition of chemicals that produce hypochlorous acid in the solution. And this whole is believed that this is the hypochlorite ion diffuses into the bacterial cells and destroys enzymes necessary for bacteria. So this is how it cleans the pool and bleaches out the bacteria, right? When I say bleaches out, it gets rid of, it's antiseptic to bacteria. So whether chlorine is used, whether that, but it has to do with this hypochlorite ion in the midst of swimming pools and actually in bleaches. So it's pretty important. So anyway, that's all for this section. We'll go on to the next.